In section 3.4, you are learning to solve multi-step equations. Basically, you're putting together what you've already learned in section 3.1 or 3.2 and 3.3. So on these, you have to do more than just one step to solve them. It is still the same concept. You're trying to get the variable by itself, and we're going to choose to leave the variable on the left-hand side, and we have to get rid of what's further away from the variable. So on this particular part, here's my variable. This is like a sibling that is tied to your leg. This one's real close. You cannot get rid of that sibling. But this one is a little bit further down the hall. So that's the sibling we're going to get rid of first. And we are going to add a 17 to both sides. When we add 17, we get rid of this 17 on this side, which is our goal. We want to get rid of everything except for the m. So that cancels out. I'm left with a 7m. I bring down my equal sign. And when I add those two things together, I get a 77. Because remember, what you do to one side, you have to do to the other side. But this problem is not done yet, because this problem still has a 7 that is being multiplied by the n. The opposite of multiplication is division. So now I'm going to divide both sides by 7. Those are equal to 1. So I'm left with m equals 11. So that's going to be your answer. The way that you can check to see if it's correct is you plug it back in. 7 times 11, so rather than write the m, I write what the m is equal to. Minus 17 equals 60. So this is 77 minus 17 equals 60. So 60 equals 60. So I know that m equals 11 is my correct answer. Let's do this one. If I have minus 13, I can go ahead and I can either add a negative 13 or I can leave it like this. So what I'm going to do is I am going to add 13 to both sides to get rid of that. If I've subtracted 13 or added a negative 13, I have to add a positive 13. Those go away. I get 5q is equal to 50. Now notice I've got to take another step. So now I have 5 times q, which I'm going to have to divide both sides by 5, and I'm going to get a q equals 10. I'm going to check it by plugging it back in. 5 times 10 minus 13 equals 37. So this is 50 minus 13 equals 37, and 37 does equal 37. So therefore I know that 10 is my correct answer. All right, now these look a little bit different. If you've noticed, and the best way to look at this is basically bunk beds, and this is a sibling that's down the hall. So this sibling is farther away than that sibling. So the very first number we're going to get rid of is that 21. We're going to add a negative 21 or subtract a 21 from both sides. So I'm left with t over 8 is equal to, and on this side that's going to give me a negative 7, okay, because these two have different signs. So I subtract and use the sign of the larger number. Notice I still don't have the t by itself, so the t is being divided by 8, so the way to get rid of that dividing by 8 is multiplying. So I'm going to multiply by 8, leaving me with t equals negative 56. To check it, I'm going to put it back in the problem. So I have negative 56 divided by 8 plus 21 equals 14. Negative 56 divided by 8 is a negative 7 plus 21 is equal to 14, and that would give me 14 equals 14. So therefore I know the negative 56 is the correct answer for T. Same thing here. This 9 is what you're going to try and get rid of first because it's farther away from your variable. So the opposite of subtracting a 9 or adding a negative 9 is adding a positive 9. So I have S over 12 equals negative 2. But again, the S is not by itself yet. So we want to multiply by the same thing that we're dividing by. And what we do to one side, we have to do to the other side. So that gives us S equals negative 24. We're going to plug it back in. Negative 24 divided by 12 minus 9 equals negative 11. This gives me a negative 2 minus 9 equals negative 11. The rule for subtraction is you add the opposite of your second number. Now I have two negative numbers that I'm adding, so I have a negative 11 equals negative 11. Therefore, negative 24 is the correct answer. These look even different because the fraction bar goes all the way across. Notice on this one, the fraction bar is only underneath that variable. But on this one, it's over that, it's underneath that whole thing. Well, if you look at it, that's kind of like this is upstairs and this is downstairs. So this sibling or number is the farthest away from that upstairs variable. So the opposite of division is multiplication. So the first move I'm going to make is I'm going to multiply both sides by 9. Those are going to equal 1, leaving me with P minus 15 is equal to negative 54. Then I have a minus 15, so I want to add 15 to get rid of it. So I'm going to get P is equal to, that's going to be negative 39. I believe that's correct. And, okay. Yeah, that would be right. Okay, if I plug it back in, I have negative 39 minus 15 over 9 equals negative 6. I'm going to add the opposite of my second number, so that's going to give me a negative 54 divided by 9 equals negative 6. That's negative 6, so I find out this is my correct answer. Same thing here. See, the fraction bar goes all the way across, so I want to multiply both sides by negative 3. Those are equal to 1, so I have R plus 8 equals positive 6. I'm going to subtract or add a negative 8 to both sides, so I'm going to get R equals negative 2. I'm going to plug that back in, negative 2 plus 8 divided by negative 3 equals negative 2. This is going to give me a positive 6 divided by negative 3. So negative 2 equals negative 2. The other thing that you have in this is you're going to write and solve multiple step equations. So rather than just having the equation, you might have to come up with the equation through verbal words. So you're going from verbal to algebraic. So if I say 2/3 of a number, that's 2/3 times n minus 6 is or equals negative 10. So there's my equation. Now I have to solve for it. I'm going to add 6 to both sides, leaving me with 2/3 n equals negative 4. Go ahead and come up here. Now, the way that I get rid of something that is multiplied is I divide. So I'm going to divide this side by 2/3. And what I do to one side, I must do to the other side. So 2/3 divided by 2/3 is equal to 1. So I have n left on the left-hand side. Don't forget keep, change, flip. Now that can be put over 1. So I'm going to get negative 12 divided by 2, which is equal to a negative 6. Let's do another one. I have 8 more, so 8 plus 5 times a number is negative 62. Okay, I'm reading the words and I'm writing the numbers and the letters that match it. First thing I'm going to do is subtract a negative 8 or add a negative 8 to both sides. So I have 5n is equal to negative 70. I'm going to divide by my 5. So I am going to get n is equal to negative 14. Okay. You also have what's called consecutive integer problems. Now, a consecutive integer is an integer that's right in a row, like 1, 2, 3, 4. Those are consecutive integers. Or negative 1, negative 2, negative 3. Remember, an integer is a positive or negative whole number. So it says find 3 consecutive even integers whose sum is negative 4. So let's put first integer, second integer, third integer. And if I say, well, let's let the first one be equal to n. To get the next even integer, I would have to add n plus 2. Because if I add n plus 1 for the second integer, that is going to give me an odd number. Remember, with the even numbers, you're skipping 1 in between. So this third integer would be an integer plus 4. So like if this was 2, this would be 4, and this would be 6. So those would be 3 consecutive integers. But I don't know what n is, but I know when I add these 3 together, I get a negative 42. So I can write my equation. N plus 2 plus n plus 4 equals negative 42. So I have 1, 2, 3 n's plus 6 equals negative 42. So now I've got to solve this. The number that's the farthest away from the variable is the 6. So I'm going to add a negative 6 to both sides, or I could say subtract it. So I'm left with 3n is equal to negative 48. I'm going to divide by the 3. It's going to give me a negative 16. And so my first integer would be negative 16, then negative 14, because I'm going to add a positive 2 to that number, and then negative 12, because I'm going to add a positive 4 to the negative 16. So if I add all 3 of those together, I'm going to get negative 42. So your answer is negative 16, negative 14, and negative 12. Let's do one more of those. 3 consecutive odd integers. So first integer, second integer, third integer. Still going to start with n. The next odd integer would not be the next one past it, but it would be 2 past it. So I have to add a 2 to that one, and I have to add a 4 to that one. If it just said consecutive integer, I would say n plus 1, and n plus 2. But it says consecutive odd, which means I have to skip 1 in between. So 3 consecutive odd integers whose sum is 57. So I have n plus n plus 2 plus n plus 4 is going to equal 57. So 1, 2, 3 n's. So I have 3n plus 6 equals 57. I'm going to subtract a 6 or add a negative 6. So I have 3n equals 51. When I divide by 3, I'm going to get a 7. Not 7. How about 17? So my first integer is 17, my second integer is 19, and my third odd integer is going to be 21. If I add those 3 odd integers together, I'm going to get 57. All right, your homework on this is page 146, 22 through 46 even.